Hey everybody. I look ridiculous. You look ridiculous. Some of you have been asking for a tour of my home office, so I'm going to give that to you now. Hold on. Yep, there it is. Okay, so today we're going to be working on Pythagorean Theorem again. The difference is this time we're going to see what happens when you have the hypotenuse, but you have to find a missing leg. Let's get ready to go. Heyo. So like that wacko with all the hats said, we're going to be trying to find a missing leg of a right triangle. If you remember correctly in your vocabulary, a leg of a right triangle usually refers to the two shorter sides of the right triangle, not the hypotenuse itself. So we've been using the formula a squared plus b squared equals c squared in order to find the hypotenuse when missing a leg. Let's review what we've been doing first. So in this question right here, we have another missing hypotenuse. We start with the formula, substitute in the values, square them, add the squares, and then, of course, say that the square root of 74 must be the answer. And so what's the square root of 74? It doesn't have an exact number, but we can estimate it there. Another one. In this case, we start with the formula again, substituting 8 and 10 for A and B because those are the shorter legs. Evaluating those as 8 squared is 64 and 10 squared is 100. Adding those together, and then saying what's the square root of 164. Although there is no exact square root of 164, we're going to have to use our square roots list and either find what it's between or what it's closest to, and you see the answers there. In question 3, we have what looks to be a Pythagorean triplet. It's the first one we ever worked on. It might look familiar to you. And so we again evaluate. 9 and 16 should give us 25. And in this case, you're going to look at your square roots list and realize that 25 does have a square root. Its square root obviously is 5. And in this case, you have an exact answer, and you don't have to write about or between because it is exactly 5. Now what about in this one? Again, we're given legs A and B. We substitute them into the formula. We evaluate 10 squared is 100, 11 squared is 121. You should be getting these straight from your list, no math. The only math you should be doing is adding the squares. And then, if 221 is the square of C, then obviously the square root of 221 would be your answer. And all you need is an approximation there, because 221 does not have an exact square root. And now to today's problem. So in today's problem, we're once again going to be looking at Pythagorean Theorem, but this time, ABC Construction brought the correct ladder, but they forgot their measuring tape. Miss McCleary wants to put a brick path down through her grass, from the cement to the side of the building. What should they do to find the missing length? Well, the missing information that you're going to need starts with, obviously, the height from the grass all the way up to the window ledge, and that's going to be 8 meters. Now you might be thinking, why would I need this information in order to put it into the grass? Well, they can't measure the grass. So they're going to need instead to use the Pythagorean theorem. But in this case, it seems that they have the correct height ladder. That information they already have. They have the height, so the missing side seems to be a leg but not the hypotenuse. So adding the squares is not going to get us the answer now. It's like if somebody said to you, well, I know 3 plus 4 equals 7, but 7 minus what is going to get me 3? It's sort of like an inverse operation here. So we know that the ladder is 12 meters long. We know that the height from the grass to the ledge is 8 meters. So now the missing information then is going to be the grass. Let's see how the Pythagorean theorem can help us with a problem like this. Now I know you want to start with a squared plus b squared equals c squared, but in this case, we're actually going to use c squared minus b squared equals a squared. That's because we're given c, and so we can leave a as the answer we don't have. C was 12, that was the ladder. B was 8, that was the side of the building. Now we evaluate those by squaring them. Just look at your list, no math. Then 144 minus 64, instead of adding, because we're taking away from the largest side, gives us 80. Now, if 80 is the square of a this time, then a must equal the square root of 80. So now it's time to take out those lists again. What's the square root of 80? Well, 80 doesn't have an exact square root, but the square root of 80 is very close to 9 because we know that the square root of 81 is 9. Now I'm going to give you an approximation of what you could estimate the answer to be. You don't have to do this, and for the homework that I'm giving you, you're not going to be required to. However, because this one is so close to 9, it's okay to say that it's about 8.9. Now you can always check that using a calculator, 8.9 squared or 8.9 times 8.9, and see how close you actually get to 80. It's going to wind up pretty close because 80 is so close to 81. However, you can't say that the missing leg is 9 because it's not. Now we're going to take the answer that we just got and apply it to a different kind of math problem. So you used the Pythagorean Theorem and found the missing length is about 9. Now, what if she now wants to make that path using these half-meter bricks? How many bricks will it take to reach the side of the building? Now, as some of you may know, in brickwork, there's this stuff that goes in between the bricks. It's called mortar. It's sort of like a paste that holds the bricks together. So she doesn't have to have exactly 9 meters to work with because the guys that are putting the bricks together can use a little less or a little more mortar in between the bricks to make it fit the exact size of the path. Now there's a few different ways you can figure something like this out. If you know there's about 9 meters to work with and each of the brick is a half meter long, then you could say to yourself, well, either how many halves are there in 9, which is one way to think about it, or another way to think about it, and make sure you're counting those bricks as they fall because it's actually the right amount, or you can think if 1 meter were to contain 2 half-meter bricks, then how many would 9 meters contain? Now, I know we got a few super mathematicians out there like Willens, Carlos, eventually Andy, sometimes Dozy. If I'm leaving you out, don't worry about it. I'll get you a shout out next time. But what I'm doing right now is called filibustering. I'm just filling time because I want to leave you guys some time to actually think about how you might try to figure out how many bricks this would fill. There are a lot of different ways. If you have algebra tiles at home, you can use those. You can use a number line in which you count by halves. You could draw a diagram. Remember, one of my rules is always, when in doubt, draw it out. So right now, hopefully you're still counting those bricks. Okay, I don't know what number we're up to now because I'm not paying attention to that. But eventually, you will see that we're going to get to the number 18. Now, 18 can be found by using the first thing I said, which is how many halves are in 9. So that would be 18. Okay, 9 divided by 1/2 would get you that number. Or you can say how many halves are in 1, and obviously that would be 2, and then multiply that by the 9 meters, and 2 times 9 is also 18. So in any case, your final answer is going to be 18 bricks. The purpose of this was to show you that not always are you just trying to find the missing side length or a hypotenuse, but maybe it could be applied a little further into some other kind of math. And eventually we'll get to 18 bricks. I think the last brick is finding its way down right there. And then this really hardworking gentleman over there on the left with his wheelbarrow with some extra bricks will tell us it's 18 bricks. Now let's look at some more mathematical type problems, the ones you're more likely to see on state tests and Regents exams. So here we have 2 pieces of information and one that's missing. Notice the one that's missing is labeled A. It doesn't have to be labeled A. In this case, you should be able to determine that the hypotenuse, or the longest side, is 13 because of where it's located across the right angle. So as always, we start with the formula. In this case, it does matter where you put the numbers because C is not the same as A or B, and the commutative property is not going to work now because the commutative property does not apply to subtraction. So we substitute in the numbers 13 and 9. We evaluate those just by simply using our list, which is 13 squared and 9 squared. And then we do the subtraction, which leaves us 88. Now, if 88 were to equal A squared, to find the answer, we're still looking for the same technique, which is what is the square root of? Okay, and the square root of 88, when you look on your list, you will not find an exact number. And that's usually the case because there are only so many perfect squares. Every other number that's not a perfect square does have an approximated square root. So what is the square root of 88? Well, a couple different ways of looking at that. You can find which it's closest to, which in this case, it's only 7 away from the square root of 81, which is 9. So you could say it's about 9. But because it's more than 9, that means it's also going to be between 9 and 10. In the second one, find the approximate length of the missing side. That word approximate should immediately tip you off that this is probably not going to be a perfect square root. But let's find out anyway. Now, how do we know that 15 inches on the side right there of the triangle is not a leg? We know this because it is not connected to, and it is across from the right angle, which is what makes the hypotenuse, which in this case is going to be labeled C for our purposes. So we substitute that in the place of C, and then in the place of B, we're going to put the 5. Now I know what you're saying, but the B is the one that's blank. That doesn't matter. Which is B and which is A doesn't matter, but which one is C does. So 15 squared, 225. 5 squared is 25, and then we're going to subtract them because we're trying to find what's left over. And so then, obviously, your next step is going to be to find the square root of 200. So because I saw some comments on Pupil Path about having trouble finding the approximation of a square root, that's why I've slowed this down so we can look at it a little more carefully. Find the numbers on your list that are closest to, but directly below 200, and directly above 200. The first one you should find is about 14 because 196 has a square root of 14. And then you just look at the next number up from that, which obviously is going to be 15. So the other way of correctly stating the answer for the square root of 200 is between 14 and 15. Or the missing leg is definitely somewhere between 14 inches and 15 inches, but it seems to be closer to 14 inches. Our next example, you're going to see no labels, A, B, or C, but we should still be able to identify the hypotenuse based on its location. Across from the right angle is the 4, so that's going to be C. We start with the inverse formula of C squared minus B squared equals A squared. And the first thing we're going to do is substitute. In the place of C, we're going to put 4. In the place of B, we're going to put 2. Which is A and which is B doesn't matter, but C is important because it's always the longest leg. We're going to evaluate 4 squared and 2 squared, and we'll get 16 minus 4. This is simple difference subtraction. 16 minus 4 should get us 12. And then 12 is going to equal A squared. For those of you that are having trouble with finding the approximation of a square root, look at your square root lists now. You should see the perfect squares start with 1, and then 4, and then 9, and then 16. 12 isn't there, but it is definitely between 9 and 16. Which is it closer to? In this case, it's closer to 3. Because 12 is 3 places away from 9, but 4 places away from 16. So you could say that the missing leg is about 3. Now, because it is more than 3 and less than 4, another acceptable answer is to say that it's between 3 and 4. Maybe you've been noticing the decimal approximations that I've been putting at the bottom. They're not completely necessary to know right now, but it's something important for your future. So I'm giving them to you anyway. For those of you that want something that's a little bit of an extension, you could try to figure out how I got those. In our next example, we have a label for A as the missing side. It seems that we've been given the hypotenuse is 10. We can tell that based on its location, which is across from the right angle but not connected to. So we'll start with the inverse formula. We're going to substitute our numbers in. C is 10, B is 8, and the missing value is A. We can now evaluate 10 squared and 8 squared simply by looking at our squares list. No math to be done. 10 squared is 100, 8 squared is 64. And now we find the difference between these two numbers in order to find the square of A. But remember, that wouldn't be the answer. 36 equals A squared. 36 couldn't equal A. That wouldn't make any sense. The longest leg is 10. How could a shorter leg be 36? That's not realistic. So you need to look at your perfect squares list, and you'll notice that we start with 1 and 4 and 9, 16, 25, and in this case you might actually notice that 36 is on there as a perfect square, which means it does have a square root. So now you cannot say the square root of 36 is about 6 or between 6 and something else, because it's not. The square root of 36 is exactly 6 because 6 times 6 equals 36, or because the square root of 36 is 6. So this one has an exact square root number, and when you're given one that has an exact square root number, you need to use that number as the answer. There's no reason to write it as an approximation. No labels here. We have 3 millimeters and 7 millimeters. Can you identify the hypotenuse before you begin and choose which formula to use, whether you're going to use the inverse or not? You should be able to identify 7 as the hypotenuse because it's across from the right angle. So you're going to start by substituting. The 7 is going to go in the place of C, and then the 3 could go in the place of A or B, but in this case, because we wrote the formula the way we did, we're going to put it in the place of B. Looking at your squares list, you should be able to evaluate 7 squared and 3 squared pretty simply, and then finding a difference between 49 and 9. 49 minus 9 is 40, and that means that 40 equals the square of A. Again, it would be crazy to think that that side that has no label on it is 40, because that's longer than the longest leg, which is only 7, which means if 40 equals the square of A, then we know the square root of 40 must be the answer. So we take out our squares list again, and we look through it. Starts with 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and you keep looking through those numbers of perfect squares until you find 40. Now obviously it's not there, but you can see what it's closest to. 40 is closer to 36 than any other number on the perfect squares list, and so you can say that that leg is about 6 millimeters, but not exactly. You can then look at the next one that comes after 36, and that would be 49, and so you can say that that leg is somewhere between 6 and 7, but you know it's less than 7 because the hypotenuse is 7. And one more time, I'll give you the decimal approximation at the bottom. Psych. No, I won't. Okay, so what's wrong with this picture right here when you're looking at it? This is going to be our cliffhanger for the day. It's going to be what I'm going to leave you with and let you think about. You can send me any comments or questions about this on Pupil Path. If you think you've figured out what it is that I'm trying to show you here, well, then that's what I'm looking forward to, is hearing from you guys. So it looks like we have a leg that's 14, a leg that's 13. Definitely a right triangle because it has a right angle. But something's wrong with this picture. I wouldn't ask that question. So remember, you can leave comments in the comment section under this video on YouTube. But more importantly, you can send me all your comments and questions, and make sure you complete your work and send those things in through Pupil Path. See you guys tomorrow.